So in a lot of my videos, I've talked about training your own StyleGAN model, StyleGAN 1 or StyleGAN 2. I haven't talked a lot about the other training options within Runway. I probably won't talk a lot about generative text just because that's not really my area of expertise, but I do want to cover object detection. Object detection is a really interesting training opportunity where you can basically train the model to learn particular objects or faces or other things in photos. So what we're going to look at in this video is actually we're going to train our own object detection model on a couple of my favorite cats. And what we're going to be able to do then is we're going to be able to quickly figure out if a cat is inside of an image. So in this case, we're going to look for Omar, Bone Bone. We'll look for a couple other cats. So I'm going to walk you through the entire process to generate one of these models. It involves basically actually, I won't cover downloading a data set. I just scrape these images of these cats off their Instagram accounts using the Instagram scraper. But I will walk you through sort of like building a training and test set, and then labeling these inside of Runway, and then training, and then using another test data set to generate our outputs to make sure it's working the way we expect it to. So this is going to be kind of a long video, but I think you'll learn a lot, and I think it'll be pretty good. So let's go ahead and get started. So before we get started in training inside of Runway, we need to make sure our data set is set up. Data set for this particular task is actually a little bit easier, I would say, than generating a data set for StyleGAN. The first thing is you just need to grab a bunch of images, right? So in this case, we're going to look at doing this with 5 famous Instagram cats. So I'll quickly just show you my favorite cats. We're going to do one with, so this will be Bone Bone, Hamilton, Omar, Pudge, and Venus Two-Face. So here we've got some photos of Bone Bone. Here are some photos of Hamilton, who has this nice mustache. Omar, who is probably the biggest cat I've ever seen in my life. Pudge, who also has a mustache. And Venus, who has this really wonderful split 50-50 face. So what we're going to train our model to do is we're going to train it to detect each of these 5 cats in any photos we send it. So the first thing you need to do is you need to actually download all these images. So I downloaded these from each of their Instagram accounts. There's varying amounts of images in each of these. So this one has about 1,000, this one has about 600, this one has 300, and this one has 2,000. So lots of images in here. Similar to anything else, you will have issues where your data set is kind of messy. For this particular task, it's actually maybe a good thing, because we also need to sort of send it some not false positives, but tell it when people aren't tell it when these cats aren't in these faces or in these pictures. So I've downloaded all these. What I'm going to do is I'm going to actually set up a training folder. So for training, for this example, I'm going to do 100 photos of each cat. The truth is it kind of varies depending on how many, on what you're training it on and some other details as well. I would generally say try to find about 100 images for each category, if not more. The task of actually labeling each of these is actually the hardest part of this whole process. So you don't want to go too high. You don't want to have 1,000 in each category because you'll just be spending all day tagging things. But you do want enough photos in here that it's worthwhile. So I think Runway recommends about 500 to 5,000 training images. So this is at 500. This will be good for us. One thing to note is that I don't really care about the size of these images. They tend to get squished down pretty small, usually in these sort of label trainings. So I just I'm dealing with whatever Instagram has. So some of these are big, 1080 by 1080, some of them are 640 by 640, some of them will probably be rectangular. It doesn't really matter. What happens is these get squished down to a square, and then it tracks our label box, and it maps it all correctly. So it doesn't really matter what size these are. So again, this is almost a little bit simpler than StyleGAN because we don't need to worry too much about resolution and that sort of thing. Once we have this data set up, we're going to actually upload this to Runway. So let's go ahead in here, let's go to train, and let's say we're actually going to pick the object detection training setup. So we're going to pick our a name for this. So we're going to call it famous cats. Create. Now I already uploaded this because it takes a long time to upload these, especially if you have a ton of images. If you have not already uploaded your dataset, you're going to click here, click upload dataset, and you're going to pick your dataset. It'll upload. It usually takes anywhere from 10 minutes to half an hour, depending on how big your images are. If you have a lot of PNGs, you might want to convert them to JPEGs. It will upload faster that way, and the compression quality really doesn't matter that much in a task like this. So you'll see already, hey, over here I have my 5 cats. Now when you've uploaded them, cancel, you will have to, you can sort of preview your data set over here, right? Your next step after this is to actually add all the labels. So let's go ahead and walk through that process. Hit next, and we're going to set new annotation group. So this is good if you have not used any other annotation groups yet. An annotation group is basically what we're going to do is we're going to create labels. So we're going to create a label for Bone Bone, a label for Hamilton, a label for Venus, and then we're going to literally go into every image and create a box around their face. So let's go ahead and get started. New annotation group. So we're going to call this famous cats. Hit create. And now we're going to create our categories. So we are going to add our labels here. So we're going to say Bone Bone. We're going to say Hamilton. We're going to say Omar. Pudge. And Venus. So now I have all 5 of my categories here. Let's just name Bone Bone. The capital letter, it doesn't really matter, but just keep it consistent. So each of these is also assigned a color. I believe you can edit the color. Maybe you can't. Okay. It doesn't matter. Again, just remember these colors are what we're going to actually label using our bounding boxes. So let's go ahead and click Start Annotating. So now we're going to go through literally every image that we've uploaded, and we are going to put bounding boxes around their faces. So there are some nice little key commands over here. So if you can, on your keyboard, you can press 5, and then you can draw a box around Venus. And in my experience, these don't need to be too perfect. I'm just going to do ears to ears, just so maybe it includes the box. Maybe there's a world in which what you eventually want to do with this is actually, maybe you want to crop to these images. So having a good bounding box is kind of nice, just to make sure that you can do the right thing with these once we've trained the model and once we're getting it. So it looks like there's also a key command here for submitting, so space. So this will be nice, and I can go through this pretty fast. So here's Venus again. Now again, you'll sort of notice that like sometimes our images aren't perfect, right? I can't really go ear to ear on this model, but these are the images I have. This is maybe how the model wants to work with this, so we're going to keep going through it. So now this is Hamilton. So I'm gonna go ear to ear, and then maybe like sort of try to get as much of their face fluff in as I can. Here's another Venus. So I will do this for about 10 or 15 of these, and then I will stop the video and do the rest of them and come back later once I've completed this. So you can see this does take quite a long time. This will definitely be the hardest part of your task in this. Now I can also like go through these. So you might be wondering like why is Venus and Hamilton showing up the most? It might just literally be that it's sorting by name. So like if I could jump ahead, I don't really recommend doing this process, but you can jump ahead. And I'm still seeing Venus, still seeing Venus. Who knows? Let's see if we can find. Okay, there's Bone Bone. So we'll do 1. And then click that. Now, if you, for whatever reason, if the task you have has multiple images in it, you can assign multiple labels to a single image, right? So let's say for whatever reason, maybe we're at like a cat convention and Pudge is also in this photo. You can add multiple labels. This is a pretty common thing for object detection that, maybe you want to detect both a car and a car wheel, and you want to have it you want to get both of the placements for both of those. So you can go ahead and add additional labels in here. In this case, for most of mine, I'm just going to have all of the I'm going to have single photos of every cat in there, but I want it to learn sort of the cat face. So if I want to remove this, I believe I can just hit delete. I can dump it here. So there's a trash can. I believe I can also just hit the delete button. No, I cannot. Okay, so I have to delete it using this. Okay, so I'm going to go through and do the rest of these, which will take me probably like an hour or so, maybe longer. So I'll stop the video, we'll come back and we'll look at what happens when we are finished with this, and then we'll go through the steps to train this. Okay, I'm about halfway through my data set here. You'll see I've submitted 275 of 500. This is already 1 hour in, so it's definitely taking me some time to do this. But I thought I'd stop, and there's a couple of good things to note here. So first off, like in this image, you'll see there's actually like a couple versions of Pudge. So we can go ahead and add bounding boxes for every photo of Pudge. This is good. Like this is actually really, really helpful, in part because the model is now seeing Pudge at different scales, and knowing that in some cases Pudge can show up in multiple photos. So this is helpful for the model in many different ways. You're also seeing the resolution of this is not great, so even better. Like now it's learning what a fuzzy looking Pudge looks like. Well, Pudge, I have to say, is always fuzzy. So I'm just adding bounding boxes to every one of these. And I'm just trying to maintain, I don't really want to deal with the back of Pudge, I just wanted to find Pudge's face, so from behind might be a little hard. So I'm going to leave it like this. So I've got multiple images here now. I'm going to submit those. Now, a couple other things to note as you go through this is in your categories here, if you hover over this, you'll see that there is a little bit of information about the model that you're currently working with. So the first thing you'll see is I've submitted enough files. So like basically there's like a minimum number that Runway suggests that you submit. So it was something over 275. The total annotations is also good. So I've submitted probably about 275 annotations. Some haven't had any, some have had a couple. So that's probably good as well. But you'll see here I've got a warning that says that I do not have yet enough sufficient examples of Omar or Bone. And the truth is I just haven't come to those images yet. I assume that of the 200 left, almost all of them will be Omar and Bone. So I'm going to go ahead and grab those, but this is helpful to know that Runway says you need about at least 25 annotations of for each of these. I would say you probably really want 50 to 100, more like 100, just in my experience, especially because for a lot of these photos, cats' faces are tilted, or like they're their mouth open or mouth closed, or it's like partially obscured. So just good to have more examples than it is less. You could go to like 250, 300, 500, but you'll be spending many hours doing labeling. So just be aware of that, but I thought this was really helpful to sort of see, and Runway does a nice job of making this clear that, there are some things you still need to work on here. Okay, I'm going to go back to it, and I'll let you know when I'm finished. Okay, so I just finished up all my annotations here. Finished 500 files. One note I wanted to make is I previously said that I didn't know how you would delete a annotation. If you hover over this little info icon here and you click on it, you'll see that you can, whoops, there we go. Just hover over it. Okay. If you hold shift, you can disable moving and resizing, so that way you can like draw over top of annotation. Sometimes you'll get into a place where you're trying to draw something right on top of it, of another annotation, and this is a nice way to fix that. Clicking on a annotation, or like hovering over an annotation and clicking R will delete it, and then left arrow will go backwards to a previous file. So some helpful hotkeys here if you're interested in being a little more efficient. All right, so now that we finished our annotations, let's go back here. So I've got my famous annotation group, famous cat annotation group, files that I am ready to go. So I have a total of 498 annotations. So some files didn't have any cats, or they like the photos were blurry or whatever, so I just didn't add any annotations. Got my 5 categories here, and everything says that I have sufficient amounts of information. Let's go ahead and click next. All right, so now here is a place where you can pick your training options. So this works just like it does in StyleGAN. You can work off their default, or you can choose from other models. So the other model options here are YOLO-v4, which is just like the basic. This is like FFHQ, but for YOLO. This is the like v4 architecture state-of-the-art results. V3 Tiny, I believe, is like a smaller version and optimized for real time. So if you're looking for like real time tracking, you might want to pick that. And then a bunch of my other models are here that didn't really turn out. So I'm going to pick YOLO-v4 because I just want to train this off of the basic. Now, basically, if like you want to choose a pre-trained or like a previously trained model, it's probably like only if you've like already trained it on similar things would it really make sense. So in this case, I'm just going to pick YOLO-v4. Now over here, we're going to pick how many training steps we do. Their recommendation is that you train for at least 5,000 steps. or 1,000 steps per category. So I've got 5 categories. That ends up being 5,000 steps anyway. So if I check my cost here, that'll be $25. So this is fine. My guess is that I might need to train for longer. Usually I train these for about 10,000 steps, but I'm just going to run it for 5,000 and I'm going to see how it goes. And if it looks good, I'll just let it go. And if it needs more training time, I'll do a continuous training and add like another 5,000 steps or whatever to it. All right, so I think with this, we're good to go. So what I'm going to go ahead and do is I'm going to hit start training. It looks like it says it's going to take about an hour. I'll see how realistic that is, but we'll click start training when I'm finished training, or maybe in the middle, I'll come back and check out how we're doing. And as always, this needs to get set up and get started. So I'm going to let this start for a little bit, and I'll be back in just a minute. We've finished, or just about finished, our training session here. So let's take a look at what's going on. We're at 5,000 steps of 5,000 steps. I think there's just a little bit of post-processing that needs to happen. We've got some example images here. It just happens that all of these are images of Omar, which isn't my favorite solution because now I can't really see how well it's doing for other images. But we can sort of take a look and see how it worked with just these 10. And I can kind of see already that this isn't like as good as I would like. So one, didn't come with any results here, which is unfortunate. It got Omar here. This is actually pretty good. I would say this is pretty decent crop. Also good. Hard for me to say. I think it did get its ear, so that's good. This one's good, but it missed a little bit of the cheek. So, you know, maybe if we trained it longer, we would get a little bit more of an improvement. Pretty good here. Pretty good. So obviously it saw a lot of faces of cats, and it sort of knows the right bounding box. Although I will say this one probably could be trimmed a little bit on the left, but so it goes. Also good. Missed a little bit of the ear, but pretty good. And not too bad on this one. Again, missing some of the ear. Part of this is because it saw a lot of images where ears were cropped, so it's probably like not fully learned all of the ears that it needs. So I think this is another case where if I train it for a little bit longer, I bet I'd get a little bit more out of it. Surprisingly enough, this one worked. I actually did not include a label on this, so I wonder if that maybe messed it up a little bit more. I didn't include a label on this because the face was so blurry, but in hindsight, I probably should have. And this one's pretty good as well. So all these Omar images are decent. Maybe I wouldn't say perfect, but they're pretty good. If we take a look over here, we're still training. I don't know what's actually going on. I think it's just probably wrapping up some post-processing here. MAP, so this is the mean average precision score. You can hover over this and read a little bit more about it, but essentially it's the precision of the labels versus what it found, or the labels I provided versus what it ended up producing. The precision here is 71%. You'll see it's yellow. That means it's not perfect yet, or not really as good as it should be. I would expect the accuracy of these to be a lot better if I fully trained it. So this is why I'm sort of guessing if I train a little bit longer, I'll get a better score here. Unlike the StyleGAN thing where I sort of say like, you know, it's fine if your numbers are low. I believe with this score should be much higher. When we do object detection, generally we're seeing scores of like 90% on average. So I think this definitely could go up higher. So what I'll probably do is I'll probably continue training this for one more step, and then we will see how it goes. So I'll probably, it looks like this is still wrapping up, so I can't yet continue from this. So in just a minute, I'll switch back over, and I'll show you how to do continue training from this step, and then we'll do another hour of training on 5,000 steps. I will say it took a little bit longer, so it looks like it took about an hour and 15 minutes. Not the end of the world. Pretty decent actually in terms of estimation. So we'll do we'll continue our training from this. We'll do 10,000 total steps and see how it goes, and then we'll do a test, and we'll sort of see how it works on images that it has not seen before. That'll be sort of the big test case. So I'll be back in just a minute to run to update and continue our training. So it looks like my model is finished now. So let's go ahead and figure out how to continue training. Thankfully, there's a little button up here at the top that says continue training. So let's click that. And we'll do continue famous cats. Sure, why not? Continue. And we're already set up here, right? So it's already set up to pick up from where we were with the famous cats and build on top of that. And I'm going to do another 5,000 steps. So overall, this model is going to cost me $50, which is kind of expensive, but so it goes for the Runway training sometimes. There's probably other ways to do this on Colab, and I might look into that and recording a video on that. But this has been a fun experiment, and Runway does make this all like very easy to use. So let's go ahead and kick off our continue training. So I'll kick this off, and then I'll be back when this is finished, and then we'll look at how to actually run a test of this model. All right, so I noticed kind of a funny thing when I was continuing my training previously. So I'll just quickly highlight what I saw, and then I'll talk a little bit about what I ended up doing to try to alleviate that. So when you continue training, ideally, it should just pick up from where it started before, which means when you pick up from this, I would expect to see in my continued training the same maps from the previous session. Instead, what I saw are a lot of these little blocks, right? And these little things are saying this is bone, bone, this is bone, bone, which is clearly wrong, which makes me think that when you continue training, maybe they're actually restarting it from scratch. So anyway, what I ended up doing after doing a second 5,000 steps, I kind of saw that it was happening. So I decided to do a full 10,000 steps, so basically I spent $100 on this model. Please watch my YouTube videos and watch all the ads so that I will get my money back on this. But anyway, I ended up so I trained completely from 10,000 steps just to sort of see what was going on here. And I did get a higher MAP score or map score or whatever. So I got up to 80%. I did not get any higher than that. I could probably train this for 20,000 steps and drop another $100 and see if I get it further. But I kind of think this experiment is good enough as is. If I look at my examples here, this Omar looks pretty good. It didn't find any Omar in this, which is a little disconcerting. Another good one, another good one. Didn't find Omar in this one, another good one. Didn't find Omar in this one. And this is the most surprising one, right? Because this is a close-up of his face, and it's found a lot of his faces in other places. This one turned out okay. This one turned out okay. And again, no Omar in this one. So it seems like it's having problems with profile views and then whatever's going on here. So 80%, meaning it will find the right score 8 out of 10 times, which is not the best, to be honest, but it might be enough for us. We'll sort of see how it goes. So I've trained this model. I'm going to give this a shot by giving it a big test. The other problem is I haven't seen any examples that are not purely Omar. So I'm going to try to see what we can do here. So anyway, we're going to go ahead and run a test on this. So I'm going to come over here, click review. I could add this to my workspace and just feed it single images at a time. What I've decided to do instead is I create a test set. This is all another 500 images. And hopefully, based on what I did, this should be a completely different 500 images than I gave it in my train set. So the idea here is that I should still at least hit another 80% accuracy. I don't even know what cat this is. This is another cat. Also another cat. So maybe we're going to see lots of cats in here that, well, that's good. Showing them weird cats, we should also get I don't know what this cat is response. So we'll see. So what we're going to do is we're going to go ahead and test on this whole test set. So I'm going to come back over here to Runway. I'm going to click on this one, which is export images and videos. Now, what's kind of cool here is you have 3 different export options from YOLO-v4. So you have visualize predictions, you have crop objects, and you have get bounding boxes. Now, I probably won't do it for this video, but in a future session, what I want to do is I actually want to get bounding boxes, because I have a theory that if I made I can make a better StyleGAN model if I took all of my cat faces and took better crops of them. So if you've seen my bone model, you'll know my bone model did faces pretty well, but everything around the face was really messy. And that's just because those are really diverse images, right? Bone has its good pose, and then the rest of his body is always in a weird spot. So I have a theory that if I go ahead and get bounding boxes, I can actually make better crops. Or I could crop them myself, but then I have to worry about squares and that sort of thing. Or I could crop them based entirely on the crop objects, but then I won't have squares. It's gonna get messy. So in a future video, I think I'm gonna try to do bounding boxes. But for this, I'm just gonna do visualize predictions, because what I really want to see is to make sure that it captured the correct crop or the correct bounding box around all of my cat photos. So in this case, what I'm going to do is I'm going to go ahead and click Browse. I'm going to upload a directory, and I'm going to click in here, and I'm going to click on my test set. And this is probably going to take a little while to upload, so I might pause the video and come back, just because this is 500 PNG images. Actually, they're JPEGs. But anyway, I'm going to pause this for a second. I'll be back once this is finished uploading. Okay, that ended up not taking too long to upload, but glad I did it anyway. So I've uploaded my 500 images here. And now we've got a couple other settings to manage as we do this. So first off is threshold. Threshold is the minimum confidence score required for a predicted bounding box. So basically, when they create these bounding boxes, it gives you sort of a prediction score, right? I believe that I have a 90% confidence that this is a photo of Hamilton, or I believe this is a 40% in 40% confidence that this is a picture of Bone Bone. So we can set this sort of higher or lower. I'm gonna leave it at 0.5. That seems like a good sort of middle ground. I might eventually play with it, more just to sort of see, like, if I go lower, will I get, more crops or more potential crops? Will I go higher? Will I get the correct crops? Anyway, we'll just sort of start here and sort of see how it goes. My output is I want images. I'm just going to do JPEGs because I don't really care about the quality of this. If I really cared, like if I were going to do crops, I would probably do PNGs just to make sure I don't get crappy resolution images. And lastly, I just want to check my cost here. So it's going to cost me 50 cents. Okay, well, that's great. Like, spend $100 on the train this model. It better not be that expensive to export all these images. So we're going to go ahead and hit export here. All right, and this will probably take maybe a couple of minutes. So I'm just going to let it run, and I'll be back again once that's finished. All right, and this finished running. So when this is finished, you can basically click on the ellipses menu and then hit download. I already downloaded these. It did take about a minute or two to download, so I'm going to go over here and take a look at this folder. So it generates a zip folder. You just double click that zip and open it up. So let's take a look and see how we did. So Venus with a 0.9 confidence, looking pretty good. Omar, 100% confidence, good. Nothing, okay. Venus, 100%. No Omar. Well, nothing's there, that's good. Omar, 100%. Omar, 100%. Omar, 98%. Pudge, that is wrong. Interesting. I don't know what cat that is, but that's definitely not Pudge. Omar, 100%. Actually, what I'm going to do is I'm going to mark some of these. This is really fun, actually. I can't believe how dumb and fun this is. I'm going to mark this as red just to sort of remind myself that this ended up being wrong. So it seems to have a really difficult problem with Omar's profile. Maybe in my test set or my train set, it didn't have enough profile images. Omar, but that turned out fine. Okay. Omar 1. Nothing in this. That's good. Omar. Omar. No Omar there. Okay. Venus. Good. Pudge. So I don't know what this is. Obviously like another cat that lives with Omar, and it's clearly like psyching it out into believing that it is Pudge. So that's good. This is kind of cute. I did actually mark in some cases this bear or whatever this stuffed animal Venus is. So it found that as well, which, okay. Probably should go back and like remove that from my feature set or my train set, but so it goes. Interesting. So this is Venus and Pudge. Okay. Hamilton. Nothing for this one. Okay, so that's kind of bad. Mark that as wrong as well. So what you might end up having to do here is, if you really want to get more accurate data, a thing you can do is you can actually add these images back to your test set, retrain with these now labeled, and hopefully it's catching it. Like that's what like a modern like production level machine learning system would do, would like take things that were false and put them back into the test set and then retrain on that, train set, test set, whatever, and sort of learn from those in a better way. So, okay, Hamilton. It's finding Hamilton pretty well. Cool. Pudge, that is correct. That is a baby Pudge, but it still found it. Okay, Pudge's mouth open isn't working. Okay, so, I mean, I would say in general, well, didn't find Pudge here either, which is fine. Did find that Pudge. Okay, really interesting. I'm like, this is like actually like, I don't train a lot of these models, so I actually have not seen a lot of these happen before. So I'm sort of learning as we go. Hamilton, is that right? That is probably Hamilton, yeah. So, this is pretty good. Like, for a couple hours of training, I did spend a lot of money, but for a couple hours of training, well, that's wrong. it did actually find a majority of these images. Like I would say, like, you know, a lot of these are, like, I would say again, like it told me I would get 80% accuracy, and I feel like that's about what I'm seeing. I feel like about every 4 or 5 is like right, and then I'm getting some that I'm like, nope, that's wrong. So, you know, we're doing pretty good. The bounding boxes are decent. I mean, I wouldn't say the bounding boxes are perfect, but they're pretty good. So interesting. Bone is, I found both bone and pudge in that one. So, you know, so far this is looking pretty good. Let's quickly go through these and see if I can find more bone images. It's really interesting that it's even able to find the blurry images. That's really fascinating to me. I mean, it makes sense what I know about convolutions, but still really interesting. That's really crazy. It found Pudge even with the glasses and the hand in the way. Okay, I'm going to skip ahead and see if I can find some bone ones. There we go. There's a bone. All right, seems to be doing good with bone as well. Cool. So in general, I'm like pretty happy with this. The extra $50 in experimenting around the continued training is a little worrying, but you know, I'm gonna reach out to the folks at Runway and sort of figure out if that's to be expected or not, because I've not really trained that many YOLO models myself, so I actually don't know. But it's looking pretty good. So like, again, what I think I'm gonna do in a next video is, or in another series, maybe not the next one in this YouTube channel, but just in a future video, I'm actually gonna use these to get my coordinate boxes, and then I'm gonna maybe do like a Python script that will go ahead, grab those coordinates, and then create a crop of those images, and probably do a little bit of a square crop just to make sure I have like, you know, give myself a little padding left or right. Like in this one, it's not clearly square, so what I'll probably try to do is square it off, and maybe even try to, like, you know, make sure it's within like a 512 or 256 size, so that way, you know, we can actually train a style GAN model on this. So I think it's a really cool technique. Gives you a lot of like, you know, production value, or like helps build a pipeline for this. So if you really want to generate a ton of data, you could. So with 100 images, you know, that I had to, or like 500 images total, 100 per cat, I was able to generate now a model that can probably do this with infinite number of photos of these animals, which in the case of something like, I think Venus has some like 2,000 images, so I can get good crops using those. So you know, this could be expanded a little bit more. I think there's more we could do here, but I think this is a pretty good start to train on your own YOLO model. So hope you enjoyed this video. Drop me a note in the YouTube channel if you have additional questions, or join the Slack. You know, this was a fairly expensive test for me, so if you're interested and you like my work, please consider joining my YouTube membership. Get lots of cool perks, as well as, you know, helping me cover videos like this. So thanks so much, and I'll see you next time.